Hello.
Hey, hey.
Welcome to You Choose, a choose your own adventure style show through the whole CNCF landscape. And we're on chapter 3, security right now.
Yes,
Yeah.
we're halfway through it, give or take.
Halfway through chapter 3. And can I say something? I
No.
like security. Oh, I said
Don't
it.
ask
Sorry.
rhetorical questions to me.
Yeah. I like
Okay,
security
go for
though.
it.
Yeah, you warned me that it might be boring, but I'm here for it. I like it. Maybe
Yeah?
because I don't
Yeah.
know very much other technologies, but I'm enjoying. So, as
You feel
someone who
safer now, right?
well, it depends. Now that I know everything that can go wrong, do I feel safer? Maybe. Or do I
Exactly.
feel worse?
That's the point of security, right? People feel safe only when they don't know what's going on. And then you ruin their dreams. Right?
Yeah. The way to feel most secure is to not learn about security.
Yeah, it's like, if you choose to go to Australia for vacation, it's an amazing place unless you get informed that there are so many animals that can kill you over there.
So it's just better not to get informed. That's what I'm learning.
Exactly.
Yeah. What I am learning from this security chapter is I didn't know. I mean, I guess I'm learning a lot about networking actually. But by learning all the things that can go wrong, I'm just like learning a lot about Kubernetes itself. How's that?
And networking is basically almost everything.
Yeah. Is that it?
Yeah.
Yeah. We have lots of friends in the chat. Hello, people. Wonderful, wonderful people. Please do say hi and where you're tuning in from, especially if you're in Australia, so we know none of the animals there gotcha.
More importantly than saying hi, start typing those questions over there. First come, first served. So
Yeah, we've
there you go.
actually been getting a lot of questions these last few episodes, and first serve is the best way for us to manage them. So if you have any image signing questions, ask them now, and we'll answer them in 40 minutes. Let's talk about last week. Last week we talked about Kubernetes scanning, and
Yes.
we had
That's
Cubescape.
the depressing part, right? That's when you discover all the things that can happen to you, right? That's the moment, that there is before and after. I was happy, now I know.
You're like skipping through the forest. There's birds chirping, and then you scan.
Exactly.
The world
And then
goes
you meet
black
a zombie.
and white. The record scratches. But the idea with those scanning technologies is not only do they tell you what's wrong, but they tell you like what you need to care about, like what even needs to be fixed. And then they give you plans for how to fix them. We talked about, wait, you look like you want to say something.
I think that's a change that's been happening for a while now, right? Traditionally, in the past, scanning tools were mostly focused on depressing you, kind of like, okay, those are 5,077 high vulnerabilities, right? Now, for a while now, I feel that it's equally important to actually explain people how to fix issues, not only to tell them that there is a problem, right?
I have a question about scanning. Do folks at the, I suppose, developer level, but when considering whether to use a certain tool, do they consider whether that tool has vulnerabilities at that moment, or is it always after the it's all fully built?
I'm going to stereotype now, right? But
yeah,
normally developers say, "Hey, there is a cool new library. I'm going to use it," right?
That's what I suspected.
Exactly, because it's cool. And it helps me. It saves me from writing, instead of writing 3 lines of code, I can write 1 line of code if I use that library. Hooray, right? And then they discover that it's slightly more complicated than that.
Yeah. And then if there are lots of vulnerabilities, does that problem go back to the developer who included that library, that tool, or is it someone else's problem?
typically to developers. At least my experience is that more often than not, people dedicated to security specialists, expert, whatever the name is, CISO, they are more focused on I'm depressing you part than
Gonna help you fix
I'm fixing it, right? Because it would be very hard, right? Imagine now that person or a small team knowing, being able to fix other people's work would mean that they would have to be deeply involved in everybody's work. Oh, this is in Java. Oh, there is JavaScript over there. There is Go. There is a bit of infrastructure, right? Done by different people and stuff. It would be very hard for them to actually implement the fixes.
Yeah. We have in chat, Sudarshan says, by using libraries, we tend to inherit all the open issues, bugs, and as well. Is we developers? Who's the we? Yeah.
Maybe it's royal we.
The royal. All of us. There have been lots of wonderful chats about networking and community building. So we'll build community by fixing all the bugs together. So let's talk about these tools we talked about. We talked about Cubescape and Sneak. Let's recap the tools.
So the short version, my interpretation of it is that Cubescape is CNCF and it is focused on Kubernetes, right?
Yes.
While Sneak is essentially older project, older company that is focused on close to everything, right? So yes, you can use Sneak with Kubernetes, but you can use it with a bunch of other things, right? The scope is much, much, much bigger, right? Now that has pros and cons, right? When you're focused on something, you can probably do a better job at that something. I'm speaking generally now, not necessarily comparing those two. On the other hand, it's very convenient to use a tool instead of a bunch of tools because it's not only Kubernetes, right? To begin with, that Kubernetes needs to run somewhere. There is infrastructure, right? Inside of that Kubernetes are containers, and inside of containers is code that also needs to be scanned and so on and so forth, right? So the scopes, the major difference from my perspective is the scope.
And Cubescape, it scans for vulnerabilities. It filters out the ones you don't want, but it also scans Kubernetes configuration. So it's like setup configuration, workload configuration, RBAC configuration. Do you know, does Sneak do Kubernetes specific stuff like that?
I'm not sure up to what level. My personal experience, which might be completely wrong, is that doesn't go as deep as Cubescape on the Kubernetes level in general, right? But because simply that's Cubescape's bread and butter, right? Like going back to the scope from before. Now, the important thing about best practices is that it's hard to actually draw a line. What is security? What is a best practice? Because most of the best practices are based on security recommendations, right? Do not open a port. That's really a security issue, right? And you will, if you look at recommendations that you could qualify as best practices or whatever Cubescape is talking about, you will see that more often than not they're related to security.
Cool. Do you think we have a question, but I'm not sure we can answer it? It's outside of the scope of my knowledge. Sneak
I
reported
have zero problem saying I have no bloody idea, so go for it.
It's on the screen now. Sneak reported vulnerabilities from Docker Runc, Cryo, etc. Can you elaborate more on them? I cannot.
Yeah, so I might be wrong, but as far as I know, Sneak is actually the company that discovered the vulnerability in the first place, as far as I know. So that's a big plus. Now, that's going around, right? Vulnerabilities are usually discovered by companies who have similar projects, right? Sometimes it's Sneak, sometimes somebody else. Vulnerabilities, in a nutshell, Runc, and Runc is part of Docker, which shouldn't matter because you're not using Docker in production, hopefully. And not because I have anything wrong with Docker, but because it's not running in Kubernetes anymore. Nevertheless, Runc, there is a vulnerability. it can essentially access the system itself and control your whole system, right? So it's pretty bad. And all you have to do is to upgrade. That's it.
Da, 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 da. It's funny that
That's, by the way, the solution to significant number of issues in security is upgrade.
Yeah. First, turn it off and on again, and then upgrade.
I mean,
We're experts.
process of the upgrade is to turn it on, off, and on again as a newer version, anyways.
It's interesting to me that the scanning companies are the ones finding and reporting the vulnerabilities. It's like a little bit like our skipping through the field thing, and they're like, "Hey, we saved you from this thing. Like, here's a terrible thing. Also, we saved you from it. You're welcome."
It's kind of one of the differentiators, even though I would argue that. So let's put it this way: in the past, different security-related companies had real differences in what they discover. Right now, those differences are much smaller. They differentiate between each other on many different levels, but in terms of how many vulnerabilities they're going to find and what they are, they're very, very similar. So it's kind of a competition. It's almost like a badge of honor. Oh, but we discovered this. We were the first one. And that means that we were the first one to implement it. You're going to get a fixed notification, everything about that specific new issue. That might be a big one or it might be relevant, but we're going to blow it up. So it looks very important. And through us, you're first to know, first to fix it, right?
Do they, when they find a bug, it seems like the socially responsible thing to do is to report it immediately. But what makes more business sense is to sit on it, build a fix. Once you have the fix, then report it. Which one do they do?
What do you think?
We live in a capitalist society is what I think.
I mean, it's hard to prove because you find out when it goes public, right? So theoretically, a person that finds it can announce it, might have announced it 3 seconds later or a day later or 3 years later, right? We don't know necessarily always, right?
Yeah.
Unless that same company has security issues and is exposed, and we can get their logs, private logs and things like that, right?
Yeah. All right, let's move on and talk about who got more votes. Which technology was chosen from last week?
So this is the part where I put it on a screen. There we go.
It is, yeah.
Cubescape.
Cubescape was chosen. All right.
Yeah.
Let's see it implemented and the demo.
Okay, let's do that. Just a second, let me open the screens, do the stuff. Where is it?
I put it.
Here it is. Okay, so you see my screen. Cool. Brilliant. I need to move the mic so I attack it. So this is going to be the easiest and shortest demo we ever did, right? Because it's easy. There is nothing special to do, right? It's Cubescape scan. Ta-da-da, then we wait and we wait and we wait. I have a cluster running already. It's scanning my stuff there. It's going crazy. It's walking around.
Everything's
right?
from our past episodes. Yeah.
Yes, more or less. You will never know because I'm not going to show you what I have in that cluster. Maybe I'm faking it. Who knows? Right? But the important part is, actually, let me be transparent and honest. Hours ago, I set up the cluster with everything we did in all the other episodes, but then I got bored and then I set up a different cluster to work on something else. But the end result is the same. It looks like it's the same. Anyways,
okay.
So here's the result, right? This is mostly a summary with a bunch of things. You can read it, you go through it. I will not bore people. A lot of red X's and all that stuff, right? And this is now based on, in case of Cubescape, on 2 security vulnerabilities, libraries, Mitra and NSA. And then you can get more information by saying, okay, cool. Show me something from the framework Mitra. I'm going to choose one of those 2. And then it does again. And now it will spit out more detailed report based on vulnerabilities from Mitra itself. And there we go. and then you have information. Okay, so this is the severity, this is the medium, high, this or that, and so on and so forth. There is some file that it
those are
outputs very.
Oh, there's a vulnerabilities. Oh, I see configuration
Yeah,
files.
critical, high, stuff like that, right? And this is a very long report, right? No, actually not that long. Long is in a file. Actually, if I put verbose, then I would get more information. Right?
What I'm trying to understand is like, what's a misconfiguration versus what's a vulnerability, like a CVE?
There is a separate scanner, separate command in Cubescape for evaluating the cluster or specific workloads. I can probably show that one as well. But before I do, let me show you what did I want to say. Yes, we can scan images as well, right? So this is one of the images that is running in my cluster. I can separately scan it. Normally, I would do this before I actually make that image available. And then you get information. Okay, so now we're not in a cluster. This is the image. This is all the bad things that you're doing, high, medium, critical, other, and stuff like that. And by the way, this is an image that I built a while ago. And I'm pretty sure that if I would build it now based on newer, I think I'm using Alpine there, I would get less vulnerabilities. They just, for whatever you have, and this is the important part, right? Whatever you have right now, the number of vulnerabilities is going to increase over time, right? Because new stuff is discovered and decreased when you upgrade. What else? I can do, okay, let me find some.
That's a good point, actually. Like with configuration scanning, that's probably something you need to scan one time because it's not likely to change, as opposed to scanning for vulnerabilities, which needs to be constantly happening because new vulnerabilities are constantly found.
Configuration, you would probably scan. So you would probably scan once every time you change it, right? Probably in your CI/CD pipelines. Now, the scanning of the cluster and even the image, because the chances that there will be a new best practice or whatever it's called is small. But now, when it comes to images and when it comes to scanning clusters and stuff like that, that should be done frequently, right? I think that one of our guests is from ChainGuard. They're rebuilding images at least once a day, if I'm not mistaken, right? Precisely to figure out what's wrong with it over and over and over again, right? So yeah, and then the different variations of the scanning, but it all boils down to the same thing: scan this, scan that. Probably add it to your CI/CD pipelines, maybe as a cron job inside of the cluster so it runs repeatedly, and live happily ever after. Depressed.
Yeah. At least you know what's wrong, and so you can fix it. Cubescape has a Kubernetes operator too to help automate the scanning of your cluster, make sure it scans regularly. Yeah.
Last time I checked, it has certain difficulties in sending me notifications. That might have changed since the last time I used it, right? And so it running in a background without me knowing is not really that useful. I'm not sure what's the current state, but yes, you can run it as frequently as you want, as an operator, as not an operator, whatever you want.
CLI? Yes.
It's easy.
Is there anything else you want to highlight from the demo?
Nope.
All right.
That's it.
We did it. So now it's time to think about signing images. We've scanned images and scanned Kubernetes resources, and now I need to sign them. What is signing?
I'm going to give my uninformed description, and then guests can correct me all they want. Basically, it goes into two important parts, right? First, to figure out what's inside. Like bill of materials, right? What is that thing? And the second part is who or what created that thing, right? Because if I know that my organization or I signed something and you want to use something from me and you see that it's not me who created it, something, then you know that you're getting something else.
My understanding is it's important to understand about an attestation. So an attestation is some sort of statement that happens at a point in time that also has associated with an identity of somebody who made the statement. And then that statement is signed, and that's the signature. So really what you're trusting is whoever that person who made the statement made a true statement. What's being verified is the identity of the person making the statement. The statement's usually like the trustworthiness of the origin.
Essentially, and this is going to sound familiar to the names of one of the projects, that's what notaries do in real life.
Is what?
Right?
Notaries in real life. Yeah.
Notaries, exactly.
Yeah,
That's what it is.
Yeah.
I go through it, I check it, this is correct, and I put my stamp there. And there are probably some laws that say that you cannot sue me if I've made a mistake, but nevertheless,
Yeah.
I confirm.
Yes. I confirm that you made this statement. What the statement says is the notary doesn't care about that.
Exactly. It is the real world one, yes.
Yeah, and I think actually the image signing one too. It doesn't verify the truthfulness of the statement. It just verifies that whoever said they made the statement. And so if you trust that organization that made the statements, that they built the image, for example, then you trust the signature. But someone can still lie to your face. A signature can't protect you from that. Is my understanding.
You might be right or you might be wrong, but I don't feel like contradicting you, and probably there are people here that are going to jump in and contradict you. So kind of, for once, I can get a break. For once.
No, please do, and I'm sure we'll discuss it too at the end of the episodes when we have our experts on to have this conversation. But I probably want to mention here too that a lot of things can have signatures, not just container images. We're talking about container images now, but you mentioned like SBOMs, for example, or binaries, when you cite a container image, it's usually like the trustworthiness of the origin, but an SBOM might be signed to say like, we found these vulnerabilities, we did this to take care of it at this point in time. And then later in the supply chain process, then it might be appended and signed again with updated information or whatever. You can use it for different things, and you can verify them in different ways, and you can make them in different ways. The signatures. We're going to find out.
So in other words, we could have done this in 3 seconds by saying anything goes.
But you feel better about yourself because you tried. Yeah. No, I don't think it's better than anything goes. Like, it does increase trust in the system for sure. But there, it's not the end all be all either, right? But let's get some experts on here instead of having you and I just feel our way through the dark. I'll say one more thing when we're considering, and I'll ask actually.
I thought, okay, she's finished. Finally.
No.
We can bring people, and she continues now. Okay. Go.
I'm going to ask you the question. I have an answer in mind, but what should we be thinking about when we're thinking about these different tools? Like, what are we considering? What's our framework for judgment?
What's our framework to judgment?
Yeah.
I don't know. My brain is not functioning anymore. I thought that you're finished interrogating me, so I switched off. Now I'm in off mode.
All right. I guess. Besides, like how its signature is issued, which is different for different projects, and how it can be verified, which is different for different projects. There's also maybe consider what happens when you need to revoke a signature. You do find that one of the signatures isn't trustworthy. Like the ones with Victor's identity, we cannot trust what Victor says at all. We need to revoke that.
Yeah, you don't need a tool to know that.
Someone accidentally.
Don't need for a tool. If you see my name in something that is floating around, don't trust it.
So how do we revoke your identity then? So like, what's the that's a third thing to consider that's maybe not as obvious as signing and verifying itself is what happens when we need to revoke a signature or an identity. Yeah.
Destroy everything Victor made.
Just blow it up.
Blow it up.
Okay, let's hurry up and get some experts on here so we can figure out what's real. I'll say when we're assigning images or any artifact, we want to identify like it comes from who it says it comes from. We're looking for authenticity, and then we're looking for integrity, that it wasn't modified from like when it got when it was made to when it got to you. So that's what a signature will help give you more trust.
It is the same thing as the thing that was signed, right?
See, what is the same? Oh, whatever artifact was signed in the first place
is exactly the same as what was signed.
It wasn't tampered with. Yes. So that's what a signature gives you more trust around that you didn't have before if an image doesn't have a signature. But let's get some experts on here. Hurry up. I want to bring on Millens first to say hello. Hi, Millens. Tell us about yourself, please.
I'm Milan Gokhan. I'm a maintainer on the Notary Project, and I work with AWS. I'm the lead developer for AWS Signer, which is AWS service for managed code signing. And I've been working as a software developer as around 20 years. More recently, it's been about using cryptography to solve security problems or to solve software supply chain security issues. And at the same time, making sure the developer experience is good.
Excellent. And I have a question for you. On a scale of 1 to 10, 1 being tame, 10 being very embarrassing, how much did Victor and I just embarrass ourselves when we tried to talk about signatures?
I think you did good. Most of it was on point. Yeah.
Good.
I think
good.
other than a little bit. Yeah.
That's good to hear. Thank you, Milan. We'll hear from you. I look forward to your presentation. Welcome, Hector. Thanks for being our guest for Sigstore. Tell us about yourself, please.
Hi, I'm Hector. I work at Chingar. I'm maintaining a Sigstore, and yeah, I think you did a great job with the signature.
Nice. Oh, it's such a relief. Thank you so much, Hector. We'll see you soon.
They're just polite people who wouldn't tell you to your face.
I want to hear the truth. Okay, bye, Hector. Gertz. Welcome, Gertz. Tell us about yourself, please.
Hi, I'm Gert. It's like I'm the maintainer of the Open Policy Container Project. So we're more the application of what you just described, signatures, to provide a secure software supply chain for policies.
Don't. It's not your presentation now.
No,
be careful. You're getting dangerously close to juicy stuff.
No, I'm just getting started. And so in my spare time, I'm a co-founder of Asserto, and so we're building an authorization platform who is actually using this technology. So we're focused on really is like what we need to actually get this problem solved. So
awesome.
I like your description of signatures. It's like it makes it really accessible for everyone to get on the same level. So.
Yeah, that's a great point. Signatures can be hard to understand, but they should be really easy to use.
It's like I was always told it's like you have to get it back to Sesame Street level for people to get it. Here we are.
Yeah, I identify with that. All right, thank you, Gert. All right, Millens, we're going to bring you on to present. Victor, are you ready to be a timekeeper?
No, not yet. Wait.
Okay.
I wasn't prepared and things happening and nobody knows how does this work. Timers. There we go.
All right.
Okay.
Come on.
Yeah.
All right. When Millen starts talking, you can start recording. Let me get Millen's
What if you keep silent just and change the slides just to buy some time? Would that work?
I don't know. All right, Millen, take it away. You're muted, just so you know, Millen.
Okay, unmuted.
Cool.
Is the slide up? Okay.
Yes.
So what does Notary Project solve? The use cases are, how do you ensure that the images that you're using are the original images that were developed by your software development team or say a third party? Another use case is, how do you ensure that the image is fit for consumption or fit for use as per your software development criteria? And these criteria are captured as attestations. They can be vulnerability scan, static analysis, 2% code review. And on a larger scale, like at an organization level, this helps you meet software supply chain security or other compliance standards. So Notary Project is a set of specifications and tools to enable use of authentic software. And how does it do that? Software developers digitally sign artifacts and attestations, for example, container images, packages, etc. And consumers of these artifacts can verify that they are indeed by the developers, signed by the developers that they trust. And digital signatures is the mechanism that enables this. Here are some of the adopters of Notary Project integrated in various tooling and products. Let's see a real life example. Notation is the CLI and libraries that Notary Project provides. So here you can see, say at an import stage, notation can be used to sign the image once you validate the image. The validate can mean verify third-party signatures, do your CV scan, open source license check, etc., and then you sign off using notation. Same at development time. You build your images, you capture any attestations like static analysis, code reviews, etc., if you want to, and then you can sign off those images. And then the signatures are stored in the same registry as your images and are distributed through registry. They can move from registry to registry. Now, before you deploy your image into, say, a Kubernetes cluster, you can use admissions controller integrated with notation to verify those images. What that means is notation will verify the signatures associated with the image and the attestations as per a trust policy that you define. Here's a quick example. Notation sign command is used here to sign the image. You specify a plugin. Here I'm using the AWS Signer plugin, and the ID specifies the key that is being used. In this case, the key is called Alice. The notation inspect command allows you to visualize all the signatures that are associated with an image. You may trust some of these signatures, you may not trust some other signatures. And the verify command verifies the signature as per a trust policy that you define. Talking about features, so you can sign and verify any OCI artifact in the registry. Signatures are portable because they are stored in the registry and they can move from registry to registry. You can have multiple signatures, and you have full control over data privacy and residency, which is like private identity in signatures or attestations can contain confidential data. You can sign with your existing key infrastructure, both on-prem and third-party services, and then using integrations, you can verify images during development or deployment time. Say Victor loses the signing key. The signing key is compromised. He can revoke the key, and that means all the signatures that he generated will be invalidated. So without any action from the consumers, the signatures are invalidated. And you can sign locally too. Here's an example of a trust policy. The trusted identity is the important part. Here you specify who you trust to sign the image. Here's a quick example of some of the verification levels that notation supports, and they can be used for different scenarios. And here's the roadmap for some of the features we are developing in 2024.
Is that the end?
Yeah.
You did it. Victor was starting to get a twinkle in his eye that your time was getting close too. Oh, you're muted, Victor. You're muted.
When you see me fiddling with my mobile, that means that
You sit up a little straighter. That was a great presentation, Milind. Thank you so much.
Cool.
I'm going to hide you back until the Q&A part of the show. And speaking of the Q&A part of the show, if you have any questions, please ask them now, and we'll get to them later. But we do them on a first-come, first-served basis. So now's the time. All right, Hector's up next. Welcome, Hector.
Hello, everyone. So I'm going to talk to you about Sigstore. Sigstore is can be conceived as a complex piece of software. And in this is one of the diagrams that explain a bit the different components in blue and what for end users and developers means. So in here, you can see how developers are usually trying to sign artifacts, and for that, they request certificates to one of the components of Sigstore, which is full show, and is a certificate authority. And that service kind of provides some signed certificates where are then hand over to a record, which is a transparency log. We can think about record about a tamper-resistant and immutable log where we can register all these kind of signing artifacts. And then we have the end users. At some point, they need to kind of verify that all these services has been signed by who and when, and whether it was valid, the validation, verification. Another of the services that Sigstore provides is cosign. It's a CLI that allows you to sign and verify any kind of artifact, starting by blobs. Then you can have images as well, and also attestations, as you can see here, right? Like we can verify, and we have additional commands than just simply signing and verifying. And these examples, you can sign blobs, you can sign attestations, and if we want to go a bit deeper and explain in details what means signing for Sigstore, I try to break it down in pieces. And here we have like cosigns where users log into the RDC provider when we are using keyless signing, and the RDC providers they return a token that is handed over to Full Show, our certificate authority, which give us a signed certificate, and then this signed certificate is sent to record the transparency log in what we call the proposed entry, which contains the signed certificate plus the hash of the artifact that we are signing and a signature, and then record like hand over a proof of recording this kind of signing of the artifact, which we call set signing entry 8 times spam, where contains the encoded version of the proposed entry and a timestamp that we use later for verification. If you're using an OICI registry, cosign kind of publish all this metadata and information to the registry, so you don't need to do anything. For verification, if it's breaking in parts again, we can think like for verifying a signed image, we need to check with Full Show whether the certificate was signed by Full Show. And with that, I wanted to say that the certificates provided by Full Show are 10 minutes valid as a short explanation, makes on purpose in order to help with revocation. Then we check the certificate that matches the signing and the issue. So in this case, we are replying with who was the signer, and verify we record the entry signed, the entry that we have signed, and also we check the timestamp. The timestamp play a very important role in order to care whether we trust the period where the certificate was valid, right? We check whether this signing was valid during this 10 minutes sort of window, and if so, we don't care about any type of revocation because this is what we base on, right? So apart from that, we check that the entry has been in record, and also we check the signature has any verification system. If we now focus on applying this to clusters, well, we have Kubernetes clusters, right? So we want to kind of verify that all our running images are secure and has been signed. So we decided to go with a single-purpose admission controller, and this admission controller supported the verifications capabilities that Cosign Verify offers. And we can, with the community of Sigstore, we decided to build this opt-in namespace admission controller, which should support also private Sigstore instances. So you can have your own Sigstore instances. You don't need to use the public one. And also adapt to have some other behaviors for cluster and per policy level. We have label selection for matching certain resources that are being deployed or not, or namespace, etc. And we also verify attestations, any attestation, total attestation that has been included into the images, such as SALSA, SBOM, vulnerability reports, And for more complex verifications, we use Q and Rego. So we support these two languages in order to define more complex policies. Again, with the community, we came with a custom resource definition, which we call cluster image policy. The community was formed also for Kibernal developers. So we came with a kind of a YAML definition. I know that we all like YAML a lot. So we came with the different components where we can express what cosign offers with YAML, so we can verify the same things such as skill assigning, attestations. We can check attestations as well, whether they are coming with specific data inside. And to finally, as part of the project, the Sigstore Policy Controller, we offer a list of example of policies that you can use for verifying response, verifying attestations, signed images of any type. And in this slide, I kind of short fragment of image policy where we are checking an attestation, which is a cycling DX attestation, which contain we are checking for a package which might contain log4j. I'm done.
Good job.
I forgot to put a timer, but it feels like it's more than 5 minutes.
We're going by Victor's internal clock for this one.
I wanted to hear that.
Yeah, we'll go back and time it, the recording. Thank you so much, Hector. I appreciate you. Looking forward to the question part at the end. Okay, last but not least, Gert Drapers. Welcome. Now you get to give us the juicy information. Right. Yeah.
Let's get going then. So I want to talk about a slightly different angles. Like we just heard, it's like two specialists talking about the signing project. It's like this is really more is like how we apply this to security software supply chain of policies, right? Policies in this particular segment being the entities that help Open Policy Agent or Topaz as an authorization framework help you implement these decisions. So how can you trust that these policies that are actually running inside your container, inside your gatekeeper, are actually say who they are, right? As you kind of described earlier, it's like signatures or to verify is like what you got from who, that you trust that person and that it's actually the same payload that you received. So how do we actually integrate that into our workflow, right? It's like if I think about Open Policy Agent, which sadly enough was not selected to move forward, but it's like, how do I actually secure this? How do I build these policies? And that's what this project, the Policy Container initiative, was started about. How do we create a workflow that developers can understand? Well, we adopted the basic flow that Docker gave us. Create a policy, sign it using cosign, just so it was just described earlier. It's like we're applying that into the wild. You push it into your registry, you pull it, you verify it before you consume it. Right? That's the basic workflow of what we're trying to achieve and automate for you as part of this. So it's a really practical point of view in terms of bringing these things together, building on top of the shoulders of it's like all these great projects that are out there. So for somebody to get started, you install it, you authenticate yourself. That claims who you are. In this case, I'm using GitHub as sort of the source of truth in terms of saying is like who I say I am. Right? I create a policy to get started, which is the scaffolding. That's not that interesting for this particular audience, but this gives me the source code payload to actually start and sign at some point. So I built this into an image, which ends up inside your local registry, right? Your local policy store or your local container store. You tag it, right? You know what you have. It's like at that point in time, you're getting ready to distribute it. So normally you would push this and pull this to the other side. Now, we forgot one step, right? It's like, how do we actually make sure that you and Victor can trust this, right? So, okay. So it's like right now is like we will pick Sigstore, right? We'll use the great work out of that project. We'll use cosign. And so first of all, we have to, again, make sure that it's like cosign understands who we are. To do that, we're logging into Docker because that's what it retrieves the credentials from. I call cosign initialize to actually get this all set up, generate my key pair, so I can have a private and a public key that I can start to use. I sign my payload, right? And so once I sign my payload, you can pull it, and with my public key, you can verify it. Right? That's the basic gesture of like how we get this going. And so then it's like, it tells me actually who I am, that this is verified, etc. So that's the basic thing that we've been trying to do, right? And trying to move forward. So it's like Google Slides doesn't like me. And so what this is doing is basically bringing a bunch of great initiatives together, building on top of open container images, so the OCI store principle, using technologies like Sigstore, enabling, in this particular example, Open Policy Agent, and therefore all its derivatives that embed that technology, providing them with a workflow that is understood by many, right? Push, build, push, pull, run. And then verify that in the middle with the technologies given. So that's it. So Victor, you don't get the dong again, sorry.
Damn it. Oh. You're a disappointment.
You're welcome.
Welcome back, everyone. Thank you for really wonderful presentations. These questions, Gert, I'm going to kind of let you decide which ones you think are applicable to answer as part of your, but these are mostly seem to be about container signing or the signing process in general. But we're going to start with this one. What info should be a part of attestations? That's something I kind of crawled through at the beginning, where I feel like an image attestation should say the trustworthiness of the origin. But what are some other examples? Milind, let's start with you, please.
Okay. Yeah, that's a great question. So it depends on the things that you want to verify. And the things that you want to verify at different stages of development is different. For example, if you generated, so say at build stage, you're building something and you have dependencies. The attestations that you want on those dependencies is who built them, and if they are like external packages, say base images, sidecars from external, like did they go through a security scan or attestations you would capture, or say a SBOM. Whereas say during deployment, you would check whether the image was signed by your internal build server. So like those are some of the examples of what can be an attestation. Any metadata can go into an attestation. It can be very customized to the software development process that you have.
And then you would customize your verification process to.
Yeah, so you would verify two pieces. Do you trust the attestation because it is signed? You can check, did somebody I trust sign the attestation? And there's this rich metadata inside the attestation that you can use to decide. I think a good example is if you're doing CVE scans, you can have a criteria that only deploy software that doesn't have a CV medium, low, medium, high, critical. And that can be your criteria.
Fascinating. So when someone just says an image is signed, what that means could vary wildly depending on an organization's signature and verification process. Is that correct?
Yeah. Like it depends on who is signing it and in what capacity that they are signing. For example, a build server may sign images built in a trusted environment, whereas a CV scanner may sign the image to denote that it's scanned the image.
Okay, fascinating.
So different signatures can have different meaning based on who generated them.
And Hector, will you weigh in about what information should be part of attestations?
Yes, sounds correct. I think that it's more important, first of all, who signed it, and also to have an idea of what is the format of what is inside the attestation, right? Like the contract. If for instance, we always talked about in-total attestations where are defined predicate types, which is one of the formats that you have inside attestation. So you can see, I want a salsa attestation, right? So in the salsa attestation, you have a format to specify everything. And for vulnerabilities, you also have a format. So you can not only check if there are vulnerabilities, but you can also check which was the scanner. Is the scanner valid? The scanner, the one that I accept the results from, maybe it's not. Things like this, yeah.
Fascinating. And Gert, do you want to weigh in on like what should be in an attestation for a policy?
It's besides all the great things that already have been said, right? It's like first of all, it's like where does it originate from, right?
Yep.
And who effectively signed it? It's like it's the tail end of the process that was just described, right? It's like the key information for is like how does it flow through the system, and at what stage inside your workflow is like do you need to validate what, right? That's ultimately is like what you're trying to achieve here, and it's like as I said, it's like we're at the tail end of that pipe, really. So it's like the questions are more around it's like who authored it, who validated it, and it's like also in terms of it's like when I think time in this particular case for us is like important, right? Is this truly the last version or the version that you should be using, right?
Excellent. Thank you. Okay, let's paint a picture where I get a third-party container image and it's not been signed. Nobody said this is a good image, but maybe I do a lot of work to make sure it's still okay to run in my system, and then I want to sign the image. Does that make sense? Are there situations that make sense to sign a third-party image yourself? Let's start with you, Hector, please.
Yeah, this is a good question, actually. I think it depends if you are in a supply chain pipeline and you have this image and you are adding something. For instance, I get an image from a product and then I scan it. Then what I will do is kind of assign on top of that image, right? So generate an attestation. That's a way. But in this case, I will probably sign anything that I don't know what is inside, right? So if it is a project that hasn't been signed, I wouldn't put my name unless that I am confident with this inside there, right? Like it's like you're not going to sign a contract of a new car that you haven't ever know what is inside, who built it, and anything.
Right on.
Because essentially the correct me if I'm wrong, right? Many of the things that were mentioned before as answers to the first question, right? Those are the things that I would need to do independently of signing, like verify whether there are high CVEs, right? And things like that. And that sounds like a process that I would probably want to do with both third parties and mine, and then why not sign it? Is that more or less the direction, right?
Yep.
I think
Document
regardlessly, right? It's like if you're using a third-party container, package, library, it's like you have to do your due diligence before you use it and incorporate it. Now, it's like signing that payload might be an attestation that is like you did that and you said it's like this is the version that is like I want to consume, but it's like it doesn't give you warranty on the car that you just bought, right? You keep using that metaphor.
I guess it greatly depends on how much I, as a company, trust people outside, anyways, right? I mean, at least I worked with companies, generally speaking, independently of signatures, kind of like, yep, that's third party. We're gonna put them through hell on earth until we confirm that that's fine, right?
I think this is like a very valid use case. Most of the images currently would not be signed till there is broader adoption of signatures. So what signatures and attestations are allowing you to do is the process that you would do as a checklist. Okay, did I check this is from a correct source? Do the open source license check? Or I'm gonna run the scanner and record the results. So instead of you recording it somewhere ad hoc, that I did this process, and then you go and tell, hey, I did this, you can use this image, you're recording it as an automated, as an attestation, digital artifact, right? And signing it. So you don't have to go and tell somebody, hey, I did this. It's recorded with the image, stored in the registry. Anytime you want to consume that image, you can check, did all those steps happen? And somebody I trust vetted this image.
So you actually, I think, answered a question that's in there. Does it make sense to sign an image more than once? So each step of the way, it's getting a new signature whenever each new information is being added and verified.
Yeah.
So the answer is yes, it makes a lot of sense to this one.
Yeah, I mean, this is totally customizable to your software development process.
Right.
Yeah, also, it can be many teams involved in signing that image, right? So you can have multiple teams, and all these teams they might sign it. So it makes sense in the process.
Fascinating. And then, Hector, let's start with you. How are certificates managed and stored?
Well, class were for Sigstore, right? So we use keyless signing, or is one of the alternatives that you have, and these are kind of way we use Fullshow for that, and then we have a certificate transparency log that is using a database, it's using Trillium, right? But these certificates they are not important to us. What is important to us is the validation, whether the time of this 10 minutes, the default time that they have, is what we care when we are verifying an image, right? If it has been signed, this artifact while this certificate was valid, right? So, but yeah, we have this with tamper resistant and transparency log for that.
Excellent. And then that's actually one of the main differentiators between Notary and Sigstore is how that's done. So Sigstore has the transparency log, and then how does Notary do it?
So with Notary Project, this is kind of a multi-part answer. It depends on the plugin that you use. The plugin enables signing. So, and we designed it that way because different customers, organizations have different requirements. They're already using some particular vendors, or they have in-house HSM, KMS solutions. So for example, if you use the AWS Signer plugin with notation, AWS Signer manages all the certificate and keys. It's equivalent to a keyless experience. We call it managed signings. There are keys behind the scene. You don't need to manage them. We rotate the keys behind the scenes. You don't have to store, manage, etc. If you use Azure Key Vault or HashiCorp Vault, you can, if you are already a customer or user of them, you get to use your existing certificates and keys stored in those solutions and use Notary Project to sign with them. And say if you don't use any of these solutions, you have an in-house PKI, you have your in-house HSM setup, you take Notary Project, you can develop a plugin for Notary Project. We have a plugin framework that allows you to get started. And then Notary Project is linked with your signing infrastructure. So there's flexibility built in on, you can use any of the providers that meet your requirements, or you can integrate with your existing solutions.
Cool. Did you have anything you wanted to add, Gert?
No, I'm happily using both of them.
Wonderful. Scott wants to know, is there a benefit using the cosign policy controller if I already have Gatekeeper or Caverno in my cluster? Or is it mainly for use cases where I don't have that already? Will you answer that, please, Hector?
Yeah, definitely. I will say Caverno is a general purpose policy engine, right? So you could use it for many other usages, and also the members, as I mentioned, they also kind of participate on the process of the defining the custom resource definition, the verify, all the different supported options for cosign. So if you prefer a single purpose that just does what you want, which is signing verification of images, and you don't really need to use Caverno or all what it implies, then you can use the policy controller, which is basically made to be completely transparent of what cosign verification does. So you might get some features in advance than Caverno does for verification, wherever it lands in cosign, but yeah, it depends on the usage.
Cool. And then this last question, I think, is a good one to go out on. Is there a benefit to using key pairs for signing over keyless signing? or is it only meant to be used if I can't use a keyless signing flow? So basically, it's my firm belief after spending a lot of time in CNCF space is that there's no like intrinsically better or worse projects. They're just different projects are better suited for different use cases. So I think I'd like for each of you, and Gert will include you too, to say like, what's a really good use case for your project? Gert, let's actually start with you and then Milind.
So I'm probably the worst one to answer this question. So
I modified the question a little bit to include you, Gert, which is just what's a good use case for your project?
So for our project is like as we're downstream from cosign mostly, right? It's like we can support both methods. Right? It's a matter of is like how to fit based on the use cases that we know of. It's like it depends on what Milind already described earlier. It's like it's what people have, right? What kind of infrastructure do they have set up? Are they managing their keys or not? We happen to run into a lot of customers that is like on HashiCorp Vault as their management solution, and so integrating with that is for us key. It's like our focus is how to enable it into the workflow.
Yeah.
Right, because that is like making it that it's getting used, and that removes the friction. Right, and that increases the number of artifacts that are actually getting signed and used as a result of that. So that's the approach we've been taking, which is sort of like coming from the other side in this particular case in terms of the theoretical like definition of like what is the advantage of keyless versus key-based, which I'll leave to two colleagues here is like who are more experts on that part than I am.
Excellent. So Milind, what's the advantage to using a key-based signing system?
So key-based signing systems, you already may have infrastructure, secure infrastructure, HSM, KMS based, that meet your organizational or external compliance requirements that say use FIPS 140 compliant key storage mechanisms. And you are not able to use the ephemeral keys, which is generally used in keyless signing. That may be one scenario that you want to use. The other would be these mechanisms also generate their own audit for whenever you use the key to sign. It has its own audit. Like for example, with AWS, you have a CloudTrail audit for every operation you've done using a key. And you may rely on those mechanisms, whereas a keyless with ephemeral may not give you that tracking, or you may depend on the transparency log to get some of that information.
Amazing. Thank you. And Hector, when is keyless good to use?
Yeah, so it's hard to say. I think Milan and Gert all information and good use cases, right? Yeah, so I think for keyless, I think the most important from the side of Sigstore is that you have transparency, right? So you can using keyless, you can check it back with the record, who did anything and what, and most of the times they are these keyless, at least from Sigstore works using OIDC providers, which Google, Azure, GitHub, which are known providers, right? That you can trust. Entities, so which is important to have those versus the HSM or any other key pairs. You need to do all the key management and then revocation. How does it work? It's probably more problematic.
Nice. I have a quick question for Hector. So one thing I brought up was revocation, which I understand Milind kind of talked about it during his presentation, that with keys, you can revoke an identity or you can revoke a signature, but how do you do that when you're verifying against a immutable public log? How do you revoke signatures when you need to? That's for you, Hector.
Okay. So revocation in Sigstore let's say that it's not what it hasn't been designed in that way to revocate, right? You have choose for revocation, what we use like TAF is a project, CNCF project. But the idea is that if you're signing with keyless, you have these 10 minutes certificates, which is valid during this 10 minute certificates. So the revocation does not apply. You just want to verify if when I signed this artifact, it was valid, the certificate, right? So that's the part of where you have key pairs you need to revocate, so then you have to remove it where it has been present, right? Hope I answered the question.
Yeah, I mean you are, but if I have an image that I let Victor sign an image, and later I was like, oh man, I don't trust that anymore. Like, I don't know what I was thinking, and but I still have those images. I was still distributing that image in my company. Can I revoke his signature and say that one's no longer good?
You can verify who was the issuer. If you saw that Victor was the one that signed it, you can kind of filter out this.
So like part of my verifier,
like a policy
part of my
engine, you can
process.
exactly,
Okay, cool, excellent. Thank you.
I have a question. Assuming that we finished with this one. When we store images, signatures as images in container registry, right? What happens if I move that image somewhere? Does the signature follow?
I can answer that. So it doesn't follow automatically. Signatures, both in Notary Project and in Sigstore, are stored as additional objects in the registry. And you can use open source tooling like ORAS copy or some other tooling which support moving both the image and the signatures. There are other solutions, like for example, with AWS ECR, image replication automatically replicates the signature as well.
With Sigstore, we have cosign copy, which is a command that helps you to move all the attestation signatures and everything when you are moving from one registry to another.
Because I'm guessing that for third party, it's a common pattern that, okay, that third party image is in Docker Hub. I'm going to pull it into my own registry, right? And then use it from there. That would probably mean that I need to use additional tools to move the signature or sign it myself, right?
I'm not sure if Harbor has any mirroring that he was if you create mirrors, it gets replicated. At least for Harbor, I knew, but I don't know the registers.
And Sebastian weighs in that they think there's a new OCI artifact type for signatures too, to include those. That's cool.
So there's newer specs, OCI 1.1, referrers API, and that defines a way to link any type of metadata, signatures, SBOM attestations with images.
Cool.
That's cool.
Awesome. Yeah. So let's say goodbye. Let's give one more reason why we should vote for you. The poll is live already in the CNCF Slack workspace. We'll put that link up in a moment. But Gert, will you give us a final pitch and a goodbye?
Final pitch is like, for us, it's like it doesn't matter. It's like as long as you sign your policies, we know where they come from. So either of these two choices, we win. Thank you.
Thank you, Gert. Appreciate you. Hector.
For us, the transparency, right? You can check the public instance and know who signed who and verified. That's
amazing. Appreciate you, Hector. Thank you so much for sharing your time. Milland, why should we vote for Notary Project?
So for Notary Project, we have really tried to implement what is useful for end developers, signing, verification, and more importantly, the revocation end-to-end workflow, and also being able to integrate with whatever solutions that you currently use.
Amazing. Thank you so much for sharing your expertise with us today, Milland.
Thanks.
Bye. You're ready to go. We gotta do our call for voting. Please vote, everyone. Come to the You Choose channel in the CNCF Slack workspace. make your voice heard.
Yeah.
And whichever one wins will implement
Let
in
me
the upcoming
put it
demo.
in a chat as well. Then it's clickable.
In the
There
chat,
we go.
and it's in the oh god, I can never remember the word for not the comments of the video, but the description, the video description.
Yeah, exactly.
You can find
exactly.
it there too.
And it's CNCF Slack. If you're not there, go.
What are you doing?
Be ashamed of yourself.
Take a long look in the mirror and then join the Slack. A few things. Next week, we're going to take on workload identity, generating workload identity. So we're going to talk about Spiffy and Spire and Athens. I'm pretty excited about that because there's so much I don't know. And Victor and I are trying to cook up a live You Choose show. It so happens that the finale of this epic security season will happen the same week as KubeCon. And so we're going to try to do a live one with the stage and stuff. We'll see.
By
But
the
we'll give
way,
you more information.
let me give a brief explanation of when Whitney said, "As so it happens." A while ago, Whitney came back to me, kind of, "We need to reshuffle those episodes. I don't think that you
Yeah.
organized it well." And now I
Yeah.
understand that she was targeting kind of, it needs to end
Oh.
at KubeCon. That's the main
That's
motivation
not
of
true.
reshuffling.
That's not true. I just didn't
So
want to have
it's-
an access control episode that had 7 projects in it. That seemed too much to manage. Like we can make this into more and that's something that makes more sense. And it just
I don't
really
believe
did
it.
just
I don't
happen.
believe that you chose sense over fame. Kind of, come on.
So we are giving a proper KubeCon talk that's 35 minutes. That will be we'll run through everything really fast, and then we're going to do a longer You Choose recap episode. That's not an official KubeCon talk at all. It's going to be like on the expo floor or something, and we'll do that, and that'll be a longer one where we really talk through all the choices we made this whole season, and it'll be a blast. But meanwhile, join us next week at the same time in the same place. We'll see you then. Goodbye.
Oh,